In this video, we're going to show you how to make a model for the Pythagorean theorem using the geometry app in the fxCG500 Casio Graphing Calculator. So what I have in front of me is what the handheld calculator looks like. So students have a stylus, or they can use their finger because it's a touch screen. And I'm on the emulator, so I can use the mouse and toggle between the menu options. As with all Casio Graphing Calculators, we have menu icons that you choose from. So we're going to go into the geometry icon today. So when I click it, notice the screen is a really nice size screen here for a handheld. This is the size screen that the students would have, and they could be doing all the work here as well. I am going to, because I'm in the emulator, I am going to change it to the other emulator mode so that I have a larger screen and it takes up more of my space so that you can see better. This is a really nice feature of the emulator because you can use it for remote learning, big demonstrations. You can make the screen much wider. So it's the same process, the same tools, nothing's changed. Students could be following along using the same exact menu options. I just would have a larger screen. So to do that, when you're in the emulator, you right click, and you'll see that this first choice here is resizable mode. So right now it's in fixed mode. If I choose resizable, it basically makes a really large window. So it's the same window that was in the fixed mode, but now it's resizable. I can make it be whatever size is gonna work for my screen or presentation. So we're gonna first construct a right triangle, because we're doing the Pythagorean Theorem model where we want a right triangle with squares coming off each of the legs and the hypotenuse. And the idea is to show that the area, or the square, of each side of the triangle each leg of the triangle rather, is equal to the square of the hypotenuses. So we're going to actually use real squares to demonstrate that. So let's make our right triangle first. And to do that, I want to make sure I'm using a right triangle, so I'm going to need perpendicular. We're going to start with a segment for one of the sides, doesn't matter which. Here's my segment tool right here. You'll see this is a picture icon way of choosing the tools that you want to use. You can also use the draw and use English words to do it that way. So I'm just choosing the line segment. So notice over here it's highlighted in blue to show me what tool I'm in. So let's just make a segment somewhere. And I'm going to go off the norm and not make the segment horizontal as we tend to always do. So here's a segment. It's going to be one side of my triangle. And I'm going to put the tool away. So notice I no longer have the segment tool. And now what I want to do is make a perpendicular at one of these endpoints of the segment. Doesn't matter which one. So let's do it at B. So to do that, I select the point where I want the perpendicular to go through, and then I select the segment line, in this case segment, that I want the perpendicular to be perpendicular to. So now I can go again, I can go to the picture options or to draw. So I'm just going to choose picture, and I want this option here because this is a perpendicular through a specific point, which I have. So we're going to choose that, and it's going to construct that perpendicular. What I want to now do is put a point on this perpendicular. So that point will be controlled by the perpendicular, and it's going to become the third vertex of my triangle, but I'll know that it makes a right triangle because it's on this perpendicular. So let's get the point tool. We're going to get the point tool. Sorry, I was looking at something. So we're going to get the point tool, and we're going to come and click on that line, and let's verify that it's on there, and it is. So even though it looks like when I'm moving it, it's not on the line, but watch what happens. It's really kind of now controlling the perpendicular because it is part of the perpendicular. So it just made the segment shorter. So now if I hide the perpendicular line, because I don't want all of that showing, I really only want the segment, the portion of the line from between B and C to show. So I'm going to hide, and you can hide anything on this. This is a full geometry software, so to hide it, I'm going to select it, and I'm going to go up to Edit, and it's part of the properties, and I want to hide the thing that I selected, in this case the perpendicular line. So notice the line went away, but the point C is still there. So now I'm going to get my segment tool again and connect the other two sides. So now I have my right triangle. Okay, so I constructed it, and no matter how I move it, if I move this C, I will still have a right triangle. If I move B, say I want to move B up here, I will still have a right triangle. They'll just be different right triangles. And so let's make A, come in a little, I want to make it just a little bit smaller. There we go. So here's my right triangle. I could verify that it's a right triangle by measuring this angle, so why don't we go ahead and do that. So I select the two sides of the angle, I go up to draw and choose measure, and I'm going to measure the angle. So you'll see that the angle is 90. Nice thing about this, and students can do it whether they're in their own handheld or whatever, is I can actually put the name of this angle in there. So this is angle B. And so now I can see that angle B is 90, and if I change the triangle somehow, let's just make it go like this, angle B is still 90, so they can verify that that's always staying a right triangle. I am going to make it slightly smaller just because we're going to be making some squares. So now the next step is, one thing I think I might do is make these three vertices much larger so that I can grab them. This is something students might want to do as well because they're working with the stylus and their fingers. So you can always change the size of anything and the color. So I'm going to change the style of these points that I've selected. I want them to have a specific color. So why don't we color them blue? And then I also want them to be larger, so we're going to make them thicker. And when I hit OK, so now it will just be easier for me to grab them as I need them. What we're going to do now is I want to show you how to make this model. I want to make a square coming off each leg of the triangle and also the hypotenuse, because we're trying to show a model that shows the Pythagorean theorem. So let's make a square, and there's lots of ways you could do it. You could do the perpendiculars again, extend the line, but what I like to use is transformations of rotation. So what I'm going to do now is make the square off of the side. I'm going to show you how I do it on one, and then I'm going to turn the video off to show you how to do it. So I'm going to use rotations because then I don't have to hide anything. So I'm going to take this side that I want to be the side of my square off of here so that they're all congruent to this side. And to do that, I'm going to use a rotation. So I can go to Construct, Rotation. So notice up here the rotation tool is showing. And what do I want to rotate around? Well, I want to rotate around either B or C. So let's do C first. And it's going to ask me what angle. Well, I want them to be a square, so 90 degrees makes sense. And so it creates a copy, a rotation of my original segment. So there's one segment. Let's do the same thing. I want to rotate the same segment, again, all congruent, but this time I'm going to rotate around B. So I'm going to choose rotation. I'm going to tell it to rotate around B this time, and since I'm going in the opposite direction, I'm going to change my angle to the opposite angle. And so now I don't actually have to rotate again to get this fourth side in, because I can just connect these two if I remember my properties of a square and parallel and corresponding and transversals, all those types of things. So I'm just going to get my segment tool and connect these lines there. All right, so now I have this square, and maybe I want to hide these 2 points because I don't really necessarily want to see them. So remember to select, properties, hide. So those are going to go away for me. And maybe I want to now make this square where it's coming off one of the legs. I want all of them to have the same color, so that might be our green square. So we're going to go into Style and choose the color. We want it to be green. And then we also probably want them to be a little bit thicker. So let's change this to say normal. Okay. And we're done. So there is my green square, right? And so if this were leg A, so A, the length of one green side is A, the area of the square is A squared. Now let's do the same. So I'm going to go and do the same for all the other ones. So I'm going to, again, choose a side. I'm going to rotate it. I'm going to pick a point to rotate around and go, I think, negative 90 at this point. Oops, wrong one. So let's undo that. Went the wrong way. So I want to be rotating 90. around this point. There we go. And then I'm going to do the same thing. I'm going to rotate around A, and this is the one that gets the negative 90. And then I'm going to connect them with the segment. So let me finish up the last one, and I will come back to you when the model is all finished. Okay, so we're back, all done. So I've made my squares, and so as you can see, they are, if I change my triangle, the squares enlarge as well. And so what we want to do first is measure the lengths of the sides of the square, which really are the sides of the triangle, right? So let's measure this first one. So we're going to select it, go to measurement, and measure the length. And we're going to label it so that it shows up. So this is the length of C. We're going to call that side C of my triangle. And it says it has a length of 0. That doesn't make any sense. Let's try that. There we go. I don't know why it's doing that. I must have had something odd selected. Let's get rid of that one. So let's try it again. Length, and notice I can go up here and actually add in some descriptors. So we're going to say length of C is 4.1. Let's look at the length of this one. We'll call this one A. And notice that when I click it, the measurement just shows right up in that window. But if I actually choose to draw the length, then I get that measurement in the screen, which is what we want because we want it to dynamically change as we're moving it. So I'm going to make that A. And then finally, let's do this one. So we're going to actually measure it, put it in the screen, and we'll call this one the leg B. Okay, so we've just measured the length of these sides of the triangle, but they're also the sides of the squares that are accompanying them. So C, let's actually move it down here. C represents the hypotenuse, which makes sense. And right now, if you were to add them up, they're not equal to each other, right? But the idea is we now know the length, so now we could actually use these and figure out the square of each of them. So A, B, C, current lengths. So what we're really trying to do is show that if I take the square, so what is the square, the green square, the A, it's A, the length A times the length A, since these are all the same length. So I could actually now create an expression. So watch what happens when I decide to do that. So an expression, the expression allows me, notice how all these have numbers, I can actually use them in a calculation. So 4 represents this side green here, right? So I could bring up my keyboard. There we go. And let's go back. And I want to do this length. So watch what happens when I click this. It brings it into the expression, and I'm going to square it. So I can type in a 2 here and close my parentheses. So I'm basically raising this length to its square, its second power, because that's how I get the area of this square here. And I'm going to hit execute, and I get an answer. And now what I want to do, if you notice, I'm in the expression mode, so I want to change it to text so that I can change what this expression represents. And I want this expression to represent A squared, so that people know what we're talking about here. So now I have, and I can move this up next to its measure, right? So if here's the length, here's the square. So notice it doesn't look exactly right, and that has to do with precision. So one thing you might want to do is actually go in and change the format of your numbers. So maybe give it a couple more decimal places so that it calculates correctly. It's rounding is what it is. And then, so now what I'm going to do is do another expression for B squared and C squared. So we're gonna do that here. So let's do another expression. And this time let's do B squared. So we're going to put B in there by clicking that number that represents it and putting in our square. And it's going to give us the solution there. And then we're going to change the mode to text so that I can change this label to be B squared. And then let's move this up. Oops. Move this up next to its side length. So we have the area, We have the length of the side and then the area of the triangle, or that side squared, and this visual represents the square, right? And then let's do the last one, same thing. So we want to get an expression, and we're going to do this C, so C is 3, and we're going to square it. And then we're going to change to the text, so I can change the label to match. And so this is C squared. And so what does the Pythagorean theorem say? The Pythagorean theorem says that this A squared plus B squared should now equal C squared. So let's see if that is true. So we're going to do another expression, and we're going to add A squared plus, oops, I believe there's plus, there we go, plus B squared, and we're going to hit execute, and there's my solution, and you can see that they do, oops, match up. Sorry, I'm not being very precise here. Oh, I have to get out of it. So let's change the text. So this is, let's change what this is. A, and maybe too much. Let's see if that works. Oh, it worked. Okay, so that's A squared plus B squared, and so we're going to put those next to each other. So in this particular instant, they match exactly, right? And so the idea is, does it match all the time, even if I change the triangle? And this is where that dynamic geometry comes into play. So let's change the triangle. So we're going to select one of the points, we're going to move it and change our triangle, and it still seems to be holding true. So we have basically made a model of the Pythagorean theorem where we see physical squares to represent that this length of the triangle side C, when I square it, I get this big red square, that's the area, and its area is equivalent to, even if I change the size of the triangle, the two legs squared as well. So just a model to represent